Hi everybody. Let's take another look at graphing with the phase shift. So a couple of you have had questions about this, so I'm just gonna try and look at it a different way. So we'll take it at a different approach. The first thing I want to go through is just reevaluate what everything means in our general equation. This could easily be a sine equation. It doesn't matter. All the difference is that if it's a positive cosine, it starts at a maximum. If it's a negative cosine, it starts at a minimum. If it's a positive sine, it starts at the axis of the wave going up. And negative sine starts at the axis of the wave going down. So that's the only thing that would change from this. What A, B, H, and K represent, that doesn't change regardless whether it's sine or cosine. So what A tells us, just need one absolute value bar. The absolute value of A tells us our amplitude. And then K, y equals K, tells us our axis of the wave. So the amplitude's the absolute value of A, y equals K is the axis of the wave. So this tells us what the middle of our curve is, and this tells us how high above that middle we have the maximums and how low below that middle we have the minimums. The B doesn't give us our period directly, but it helps us find the period. The period is always 2 pi over B. So the B tells us our period, helps tell us our period, sorry. It doesn't tell us the period directly. And then H is your phase shift. So each variable tells us something about the curve. So before this whole remote learning, we had talked about amplitude, we had talked about axis of the wave, we had talked about the period. This is the only new stuff. So I hope you guys are okay with these three. So let's talk about doing our phase shift by starting with just these three. All right. So I have an equation here. Now, the first thing I'm going to do is I'm just going to break down and identify what A, B, H, and K are. So A is the absolute value of, or A is 3 rather. B is what's multiplied by the x, it's pi over 3. K is -1 because it's supposed to be plus K, so if it's minus, it's negative. The thing we need to do, though, for H is it's supposed to look like B times the quantity x minus H. That is not B times the quantity x minus H. So we need to factor out B. Factor out B. B is pi over 3, so it's x. You're factoring out positive, so it stays negative. And if you're factoring out pi over 3 from 2 pi over 3, you're left with 2. Remember, when you're factoring out, what you're doing is you're dividing. That's how you factor out. You divide out the value, and if you do 2 pi over 3 divided by pi over 3, that is the same as multiplying by the reciprocal. The reciprocal of pi over 3 is 3 over pi. The pi's divide off, the 3's divide off, leaving us with that 2. So that's how I got that -2. So now we know H is 2 because it's supposed to be minus. It's supposed to be minus, so if it's minus, h is positive. So h is 2. So what this tells us is 3 is our amplitude, y equals -1 is our axis of the wave, our period is 2 pi over 3, which if we do the same thing we did here, multiply 2 pi by 3 over pi, the pi's will divide off, and 2 times 3 is 6. And our phase shift, it's just telling us to shift it to, and it's positive, to the right. So I'm going to ignore the phase shift and just work with these. So right now, I'm just going to write down the 3 that we want to start with. The amplitude is 3. The axis of the wave is y equals -1. And the period is 6, because it was 2 pi over 3, which simplified to 6. So when we're graphing, we know the middle of the curve is going to be -1, and the maximums are going to be 3 above -1. So that means our maximums, 3 above -1, is 2. Our minimums will be 1 amplitude below -1. Well, 3 below -1 is -4. So these 4 things are all we need to know about what's going on the y-axis. And then on the x-axis, our period, it was a positive cosine. So it starts at a maximum. And the period would look like this. Our first period would just look like that. It starts at the maximum, goes through the axis of the wave, then to the minimum, back through the axis of the wave, and then ending at a maximum for our first period. So this is one period, and it's broken up into 4 sections. 1, 2, 3, and 4. Each of those sections is 1/4 of the period, which is 6 over 4, which is 3/2. So none of this is the new stuff. This is all the stuff that we had done before. So let's graph our sinusoid just using these pieces of information. I'm going to put my y-axis, and our axis of the wave is at -1, so I'm just going to raise my x-axis a little bit above the halfway part. Our axis of the wave is at -1, and our maximums are at 2, our minimums are at -4. So on my y-axis, I want a scale that would have 2, -1, and -4. So just a scale of 1 would have that. That'd be 2. That'd be -1 and -4. We don't need anything above 2. We don't need anything below -4. All we know is that there's an axis of the wave here. So our scale on the x-axis, that comes from our period, our quarter of the period. So that's going to help us with our scale on the x-axis. So our scale on the x-axis, if we want 6 3/2, well, if I do a scale of 1/2, that would cover everything. Every 3 tick marks would be a quarter of a period, and every 12 tick marks would be 1 period. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's -6. So we'll be able to see 2 whole periods. All right? and it was a positive cosine, so it started at a maximum. So this curve, we're at the maximum. Then a quarter of a period later, so 3/2, we're at the axis of the wave. Then a quarter of a period later, we're at the minimum. A quarter of a period later, we're at the maximum. I'm sorry, at the axis again. And then back to the maximum 3/2 later. And then going backwards, 3/2, back at the axis. Backwards 3/2 at the minimum. Backwards 3/2 at the axis. And backwards 3/2 at the maximum. All right. So if I drew my smooth curve through that, that would be our graph. I'm not going to draw a solid smooth curve because this isn't everything. This is everything except for our phase shift. So I'm just going to do dashed lines. So this dashed sinusoid is everything except for our phase shift. So now we can address our phase shift. Our phase shift, so this was everything except the phase shift. Our phase shift was 2 to the right. So if you're okay with everything except the phase shift, you can graph it with everything except the phase shift. Just ignore that phase shift and then treat the phase shift as the very last thing to do. So because it was pi over 3 times x minus 2, our phase shift is 2 to the right. So that's telling us we're going to take this curve and shift it 2 to the right. Well, each tick mark is 1/2, so 4 tick marks is 2. So if I take this point, shift it 1, 2, 3, 4. This point, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, and that's going to be off the graph. So we have this curve. Now, if you want to go all out, I would accept this. If you want to go all out, you can continue the pattern going backwards. It doesn't stop this from following the pattern every quarter of a period. So if we went back 3 tick marks, which was that quarter of a period, oops, put it over here, 3/2. If you go back 3/2, 1, 2, 3. Oh, wait a minute, 1, 2, 3. Yeah, we're at the axis of the wave. So pass through like that. So if you want to fill the whole plane, you could do that. Now, do you think I would have a problem with you having 2 graphs on your same plane? No, that's not a problem. As long as you're clear which one is the answer. So if you want to use dashed lines, like I did, to show that this was before the phase shift, because we didn't even need that curve. All we needed were these points. But I will say, I do recommend dashing the curve. Because if you're just using a pen or pencil and it's not color-coded, and you have these 2 points next to each other, it's going to be very, very, very easy for you to pass through the wrong point. All right, if you're going up, then down, and you accidentally go through that one instead of this one. So this is just another way to approach the phase shift of a sinusoid. All right, hit me up if you have any questions. Bye.